I'm Ali, and we are design team 3, and our design project is the chicken robot, kitchen robot. And before we start working on the design of our project, we did some research, and we found out that most of the robotic arms that are available in the market are that can be used like in household, like and capable of carrying like heavy objects, and it's like beyond our budget. So another more thing about our project is that most of the robotic arms that are available in the market is like very automatic and precision-based robotic arm. And about the control, for the, if you guys see the picture at the top, it's a robotic unit called the Meal Buddy that very like precision based, like the user can have no control on the robotic units. And one more thing about the control of the robotic arm is most of the people like manual control, and they think of automatic control is too easy and convenient. The idea of our project is to build a wall-mounted robotic arm that has 5 degrees of freedom in X, Y, and Z, and a rotational gripper, and capable of carrying heavy objects and steering food. And the target of our project is everybody, but in particular people with quadriplegia. And however, our project is designed for a person whose name is Doug, who's like had a car accident when he was 18 years old, and he suffered from quadriplegia. And the goal of our project, of our robotic arm, is to help him carry heavy objects and prepare some kind of food and do any other task in the kitchen that require power or muscular power. The customer need and the requirements of our project is, first of all, the capability of the robotic arm. Our project will, or our robotic arm will be able to carry heavy objects such as a pot full of water and the maximum weight of 40 pounds. And we has the robotic arm has a gripper on one side that carry and rotate and stir food, and in the other side it has a hook that carries the heavy objects. And the robotic arm has sensors that give a feedback to the user and ensure the safety. For the control interface, the robotic arm will be controlled by a joystick, or a controller that has 3 joysticks and 2 buttons, one to reset and one to home the machine. And all these joysticks will be programmed to control in certain Cartesian movements. Other miscellaneous needs for the project is the look of the project, the look of the robotic arm. It will look like any other furniture in the house, and it will be robust. Also, the uncomplex design of the robotic arm, so it's easy to maintain, and other people can easily replace any mechanical and electronic components. And finally is the program, the software programming of the robotic arm will be based on basic assembly language that any person with basic knowledge of programming will be able to add code and modify it.
Okay, I'm Kake, and I'm going to talk about the 3 conceptual designs that we came up with. There were actually other ones, but the 3 main ones are detailed here. And this is the feasibility rankings graph, so we listed a lot of the stuff that like he said, and including aesthetics. And so we realized that the first concept, the triple joint, it's not as good because it just doesn't rank as much. And this is the first one that we talked about. You can see this looks very much like the commercial products that you can see that you can buy. And the problem with this concept is we have to program it to move in directions where each of these joints will have a motor, and they have to basically share the loads that they're going to have to move. But because of that, then the motors themselves will have to be very strong, and that is one problem. And even though it's flexible, the coding complexity of this compared to Cartesian, which is just going X, Y, and Z, this will be more complex to code. And because of that, then it's harder to code and it's harder to upgrade. So one of our customer needs was that the product has to be able to be upgraded by future engineers. So this was not our favorite pick. And also, this setup, it's not very safe because we would have to put this on either the wheelchair where Doug is using, and to lift really heavy load, then it means that the base right here will have to be really heavy, or it has to be bolted on the wheelchair. So, but that is not a very good idea, because if it somehow breaks, and everything just gonna fall off, and it's too dangerous. Because one of Doug's needs was to cook pasta, and there will be a pot of boiling water, and we don't want that to happen. And this is the second concept where we decided to actually just mount the robotic arm against the wall of the kitchen, and that would be this part, which is the x-axis. And since it is just going 3 directions traditionally, and that would just be very easy to code, and it's also very easy for the user to visualize where it's going, because it's very straightforward to see as opposed to a 3-joint one. So so this is basically what we decided, and I had the graph of the joysticks there, and with the little Bluetooth signal, because that's what we first thought of. Did you mention that we're going to actually have a wireless control for this? So this is because this is for kitchen, and if there are wires coming all over the place, and it could be very dangerous, especially when Doug is operating on a wheelchair. So if he trips over it, then it's not good. But we're not going to use the Bluetooth wirelessly. We're using X-Speed, which is part of the Arduino radio wireless. And so this was good at the point when we picked this, but there was one problem: is this Y arm, it extends right into the kitchen bench. So it's very difficult for it to move around, or even to retract the whole thing when Doug is not using it, or someone else wants to use the kitchen bench. So we decided that that is one problem, and we wanted to solve it. And the motors here and here, they're gonna have to be strong as well to lift the whole grip, and the gripper has to have a very strong motor to twist when it's carrying some heavy pots or anything that's heavy. So this one is the third concept, which is basically an improved version of the second one, where instead of being strictly X, Y, and Z, we have X, which is this one, and this will be mounted against the wall, and there will be a Y track that moves along the x-axis, and then this will be a rotational arm. So instead of going front and forward, it will actually just move in the Y direction and bend it inward if you're going Y direction. That way, the benefit of that is if you don't want to use the robot, it can just completely hide. So it will just be against the wall. The entire thing will be against the wall. And because of the problem with motors, which are pretty expensive, if we want it to be really strong, we decided that the gripper, to carry things, are gonna be designed to just carry very light loads, so that we can use weaker gripper motor for the rotation. And for heavy loads, we're gonna just put some hooks that are bolted on the end of the arm, So then if you want to lift something heavy, you can just lift it. Yep. Oh, and for that one, because 3 out of the 5 motors that will be on the arms are going to be all against the wall, so the wires will not be very prominent and wouldn't be sticking out into the kitchen bench. So I'm also going to talk about the budget. Our project is very heavy on the mechanical part because of the actuators or rails and the motors are actually all quite expensive to buy. So you can see the actuator is half of what we are going to spend, but this problem is going to be solved by the next slide. And our sponsor is a mechanical engineer, so he's actually going to build us the X-rail. So then we actually not going to have to pay for that. But yeah, so our part to do this project is just to design the algorithms of how the arm's gonna move and the coding and of course the wireless setup, and that's what we're gonna do. So we cut off that $260 budget, and the remaining is still just the motors and the rest of the miscellaneous stuff. And the actual electrical part, the wire, the circuits, and the coding, we are going to use Arduino and using it part of Arduino's XP radio wireless, and that is actually a total less than $100. So hopefully it will be within budget.